Global changes are reshaping our environment in profound ways. One of the most critical challenges is climate imbalance. Among these is El Niño, a climate phenomenon where sea surface temperatures in the eastern Pacific Ocean rise above normal, disrupting global weather patterns.
Kebakaran hutan dan lahan di wilayah
darurat karhutla Kalimantan.
Its effects are strongly felt in Indonesia, especially on the island of Kalimantan, one of the most fire-prone regions in the country. During strong El Niño events, the dry season extends, rainfall drops significantly, and peatlands become highly flammable. Between 2015 and 2019 alone, over 1.7 million hectares of land in Kalimantan were lost to fires. Yet, the impact of El Niño is far from uniform. Each province, and even each district, experiences different levels of risk. Global prediction models often fail to capture these local variations, leaving gaps in prevention and response. Data-driven mapping for Kalimantan helps governments and communities prevent future forest and land fires.
This study begins with a clear methodology designed to analyze and predict El Niño's impact in Kalimantan.
The first stage is data collection. Historical climate data, including rainfall, temperature, and hotspot records, were gathered from BMKG and other reliable sources. The dataset covers the period from 2018 to 2024, focusing on months most affected by El Niño across the provinces of Kalimantan. Next is data pre-processing. The collected data is cleaned, filtered, and normalized to ensure quality and consistency. This step prepares key parameters so the model can process information efficiently. The regions are then grouped using the K-means clustering algorithm. This method groups provinces based on similarities in climate and hotspot patterns, revealing clusters with similar risk levels. Prediction is carried out using the random forest classifier. This algorithm learns from historical patterns to forecast potential El Niño risks for each region in Kalimantan. The model is validated using performance metrics such as accuracy, mean absolute error, and root mean squared error to ensure reliable and trustworthy predictions. Finally, the results guide conclusions and recommendations, helping stakeholders design better prevention and mitigation strategies for vulnerable areas in Kalimantan. Based on modeling and data analysis, the El Niño phenomenon is predicted to recur and have a significant impact on the Kalimantan region. Predictions indicate that El Niño will begin to manifest in February 2026, with peak high temperatures expected between May and July 2026. The phenomenon is anticipated to persist until the end of 2027, before gradually declining from August to December 2027. These predictions were generated using the random forest algorithm, which demonstrated excellent performance with very low errors, MAE of 0.0023 and RMSE of 0.0482. The R2 value reached 0.99, indicating extremely high predictive accuracy and showing the model's strong capability to recognize both the occurrence and absence of El Niño conditions. Cluster analysis grouped regions based on the intensity of El Niño impacts. South Kalimantan and parts of East Kalimantan fall into the strong impact cluster, experiencing the most significant decrease in rainfall. Central Kalimantan and other parts of East Kalimantan are in the moderate impact cluster, while West Kalimantan and North Kalimantan tend to experience lower impacts. These findings underscore the need for heightened vigilance in regions within the strong impact cluster. The results confirm that El Niño's impacts are not uniform across regions. The diversity of local conditions necessitates tailored mitigation strategies based on local and spatio-temporal data. Implementing region-specific, data-driven adaptive approaches enabled by the critical role of data science in analyzing, predicting, and interpreting climate patterns allows for more effective and sustainable El Niño mitigation efforts.